All right, IM1 classes. Today we're talking about the distance formula. The distance formula is used to find the distance between 2 points in a graph, right? So what we're going to learn today, I'll go ahead and show you guys what the distance formula is, and then explain to you why we're not going to use it as it's traditionally written, because it's a little bit of a mess, and you'll know what I'm talking about once you see it. So the distance formula in math, so if you're given 2 points, x1, y1, and then x2, y2, the distance formula, to find the distance between those 2 points, it's the square root of x2 minus x1 squared plus y2 minus y1 squared. So as you can see, this is kind of a mess. When I was in school, I had to memorize this, and it was really hard for me to memorize. Now I have it memorized because I teach it every year, but it was really hard to memorize, and I hated this thing. There's a lot of mistakes to make along the way, putting things in here, making mistakes subtracting. Can be difficult. So instead of using the traditional distance formula, what we're going to do is just continue to use Pythagorean theorem. And the reason why we're doing that is because they are in fact the same thing. So if you remember, Pythagorean theorem is a squared plus b squared is equal to c squared. And I'm going to just actually rewrite this a little bit so it matches the distance formula a little bit. So I'm going to put c on the other side. So c squared is equal to a squared plus b squared. If you square root both sides, so square root here, you get c is equal to the, should have worn that in black. C is equal to the square root of a squared plus b squared. So you can kind of start to see how these are starting to look the same. If you change the distance formula, so saying x2 minus x1, since that's just one value, so if you subtract those and just call it, let's say you call it a, right? And then the difference between the subtraction of y2 minus y1, you call that b, right? You get the same thing. So the distance formula is based on Pythagorean theorem. So let's look at some examples how to actually use this here. So we're going to find the distance between the line segment here. So if we were to use actual distance formula, we would need to know the coordinates. So the coordinates of this one is 1, -1. The coordinates of this point would be -3, 2. And then you would put those values into the distance formula, and you would have to work it out. And I'm doing this very quickly because I'm not going to work it out this way. So instead of doing it this way and evaluating all that, like I said, we are going to use the Pythagorean theorem. All right. So what I'm going to do is make a right triangle between the points. So you just go straight down and then straight over, or straight over, straight down. It doesn't matter where you make the right triangle. Make a right triangle out of that segment. And then you're going to label it. This is the hypotenuse, so this is C, and then these sides would be A and B, right? So we have, we're going to use Pythagorean theorem, a squared plus b squared is equal to c squared, right? And just count the side lengths. So 1, 2, 3, so that's 3. 1, 2, 3, 4, so the side length's 4. And then we're trying to find how big x is. So a is 3, b is 4, c is x. I should clean that up just a little bit. So there's 3, 4, x. So you get 9, 3 squared is 9, 4 squared is 16, x squared is x squared. 9 plus 16 is 25. Solve for x, you're just going to square root both sides. So square root of 25 is 5. So the distance of this segment is 5. All right, let's look at another example. So here, I'll find the distance of this line segment. So again, you're going to make a right triangle. I'm just going to go straight over, straight down. Count the side lengths. So this one is 1, 2, 3, 4, 5, 6. This one is 1, 2, 3, 4, 5, 6, 7, 8. And then we're trying to find the side length x there. And so I'm going to label it this with a different color. So the longest side is always C, and then A and B are interchangeable. So putting this in Pythagorean theorem. So Pythagorean theorem is a squared plus b squared is equal to c squared. A is 6, b is 8, c is x squared. 6 squared is 36, 8 squared is 64. X squared, 36 plus 64 is 100. And then square root both sides. Square root of 100 is 10. We're done. Let's do one more with a big, or with the segment, with the graph. So again, you're going to start off, make a right triangle, count the side lengths. So this one here is 1. This is 1, 2, 3, 4, 5, 6, 7. And then we were trying to find the side length x. So a squared plus b squared is equal to c squared. Side lengths A, B, and C. So C is always the longest side. The A and B are interchangeable after that. So just A and B. So plug in these values. A is 7, B is 1, C is x. 7 squared is 49, 1 squared is 1, x squared is, and then we have x squared, 49 plus 1 is 50. And then you square root both sides. So since 50 is not a perfect square, you need to do a buddy system on it. So 50, the square root of 50 is, 50 splits into 2 times 25. 25 is 5 times 5. So you put those back in the radical. So 2 times 5 times 5. Look for pairs. Pair of 5s. For every pair, one goes on the outside. So you get 5 root 2 is equal to x. So the distance of C, we'll leave it as 5 root 2. All right. So on your problems, you're not always going to be given a graph. So you might just be given the coordinates of the points. And so we're still going to use Pythagorean theorem. All right, but it's going to be a little bit different. What you can always do, you can always get some graph paper. If you have graph paper, you can find some online. You can take it, you can plot these points on a graph paper, on a piece of graph paper, and then make a right triangle that way. That's always a way to do it. I'm going to show you how to do it without having to do graph paper. So if we recall back to the original distance formula, and this is going to help us, the distance formula is just the difference of the x coordinates squared plus the difference of the y coordinates squared. All right, so the A and B, if you're looking at this, the A and B, just the A is how far up and down it goes, so that's the distance in the y direction. The B, how far left and right it goes, that's the distance in the x direction, right? So again, those are interchangeable, but what it is, you're just counting how far it goes straight up, how far it goes straight over. You can figure that out just by looking at the coordinates of the points. So what you want to do is look at the x coordinates. All right. So from 3 to 8, what is the distance from 3 to 8? How far would you have to count in a number line? To get from 3 to 8, you would count 5. Right? Then think about how far does it take from 7 to get to -5? How far apart are those on a number line? All right, if you had a number line, you count, those are 12 apart. All right, so again, you can just find a number line, or you can do 7 minus a -5, but just think how far apart. All right, from 7, it goes 7 to 0, and then 0 to -5 is another 5, it's 12. Anyway, these are your A and B. So A would be 5, B would be 12, and you still use Pythagorean theorem. And then C is again be the distance between the points. So A is 5, B is 12. You can change C to X, or I'll just leave it as C this time. So 5 squared is 25. 12 squared is 144. 25 plus 144 is 169. Square root both sides. You get 13 is equal to C. So the distance between those 2 points is 13. All right. So let's do another example. I'm going to rewrite these points so I have a little bit more room. So 0, negative, or no, 0, 3. And then -3, -1. So again, you want to think, how far is it from 0 to -3? That's 3. How far is it from 3 to -1? That'd be a total of 4. So from 0 to -3, so that'd be, those numbers are A and B. So A squared, A is 3, B is 4, C, just leave it C. So it'd be 9 plus 16 is equal to C squared. 9 plus 16 is 25. Square root both sides. You get 5 is equal to C. Let's do another example. So again, how far apart are the x coordinates? So from, how far is it from 0 to -2? That's a 2. How far is it from -1 to -7? 6. So that's our A and B. So A squared plus B squared is equal to C squared. A is 2, B is 6, and we can just leave C as C. 2 squared is 4, plus 6 squared is 36. 4 plus 36 is 40. Finish solving for C. I'm going to square root both sides. 40 is not a perfect square, so we have to do a buddy system. So 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. So put those all back in the radical. 2 times 2 times 2 times 5 is equal to C. Look for pairs. Pair of 2s, one goes on the outside. Cross it out, so you get 2. 2 on the outside. 2 times 5 is 10 on the inside. So the distance between those 2 points is 2 square roots of 10. All right, let's go ahead and just do one more. So I'm going to write these just so I have more space between them. So 8 and -8, 7 and -2. So how far apart are 8 and 7 on a number line? They'd be 1 apart. How far apart are -8 and -2? They'd be 6 apart. So that would be our A and B for the Pythagorean theorem. So A is 1, B is 6. We'll just leave C as C. 1 squared is 1, 6 squared is 36. C squared is C squared. 1 plus 36 is 37. Square root both sides. 37 is not a perfect square, so you need to do a buddy system on it. 37 is a prime number. It has no pairs. So when that happens, you just leave it as the square root of 37. So if there's no buddies, it doesn't simplify. Your answer is that. Okay. That's all I have for you guys. If you have questions, make sure you email me. Other than that, we'll see you next time.